We're back. You're back. Hey, everyone's back. This is good. We're going to continue to look at limits, and there's actually three main ways in which limits fail to exist. That means they don't exist. There is no limit. It is undefined. The set of solutions is the null set. So just looking at that, the first one we said, hey, what happens if the left and the right-hand sides approach different numbers? The left side's going to 4, the right side's going to 2. Well, that's kind of confusing. Is the limit 4? Is it 2? Is it in between? We don't know. It doesn't exist, okay? So the second example of limits that don't exist would be functions that are unbounded. All that means, ladies and gentlemen, is that that function is actually going towards infinity or negative infinity. A limit is actually supposed to go to a real number. If your function doesn't approach a real number, there is no limit. So, if not, that means it's probably getting bigger and bigger and bigger forever, which means it's unbounded. Okay, so let's take a look here. I'm going to erase the 3, and we're going to take a look at this limit at -3. -3 sounds like the place to be. Notice that the left-hand side and the right-hand side definitely do not agree. As I approach -3 from the left, I go -5, -4, -3.5, -3.25, -3.01. As I get closer, this function seems to be moving along a vertical asymptote. It's getting infinitely larger. And as I come from the right-hand side, -1, -2, -2.5, -2.9, -2.99, that function is moving towards negative infinity. This actually fails in two different ways. The left and right-hand sides do not approach the same value, and this function is unbounded. So I would say that for this one, it is undefined. It does not exist. There is no solution. The set of solutions is the null set. Okay? Now, I'll talk about this third one. Make sure you write that down, oscillating behavior. I'll show you an example. But right now, I want you to try some of the limits that are on here yourself, looking especially at that function, the Hannon function. Look at the 4 limits that I have asked you to find on the right-hand side of the board. Please pause your video and make sure that you find out what these are on your own before continuing on. Take a moment now and find those limits. So here's your answers. As you're approaching -4, as the x-coordinate goes close to -4, the y-coordinate's close to 5. Both from the left-hand side and the right-hand side, my function seems to agree. That's where the height is, the y value, the y-coordinate. At x approaching 7, you'll notice the left-hand side seems to be getting closer to 0. The right-hand side seems to be getting closer to 7. Those two values do not agree. Therefore, it does not exist. It does not exist. Same thing for number 9. It doesn't exist there, but mainly that's because it's going up towards infinity. That is not a real number. Infinity is just a concept or an idea. That means it grows without boundary. So that boundless behavior or unbounded behavior means the limit does not exist. And then finally, for the last one, at x equals 5, it looks like our function has a value at 0. Now, here's a couple of tricky ones to make you think about what's happening. I have 2 common sense questions here. This is going to go more towards some infinite limits or one-sided limits that we'll look at in just a little bit. But as x approaches negative infinity, in other words, as it gets smaller and smaller, what does the function move to? And when x approaches positive infinity, this is a tricky question. Think about it and answer it before continuing with the video. If you said that the first limit there was approaching 3, you are correct. This seems to be leveling off at some form of horizontal asymptote. And I think that it's going to continue going on and moving in that same direction. That's what everything indicates here. However, down there, it seems like our function will continue to get smaller. And if it continues to get smaller, that means the actual function is moving towards negative infinity. That's not a real number. We're going to say this limit does not exist.